Good morning, students. Today we'll start with our one of the important concept of our fourth unit is what is meant by this TCP segment. Here we have the two transport layer protocols. One is a TCP and the one is a UDP. Whenever if we have a connection oriented service, the best example for the connection oriented service is the TCP. Okay, now we'll learn about what is a TCP segment. That means how the packet in TCP is called as a segment. That means for each and every packet, the complete for data, what way is going to be stored at each and every packet. Okay. Now a segment consisting of segment header and data. Okay. And the segment header consisting of 20 to 60 bytes. The header is 20 bytes if there are no options. Okay. And if there are any other option, the length of the header varies to 60 bytes. Okay. Now here, now this is a packet format. That means we can also call it as a segment format. Here we have the header part, then we have the data part. And its source port address is 16 bits and destination is 16 bits. Now each and every part will learn in the continuous session. Now first part is what we have, what is meant by this source port address. The source port address defines the port number of the application number in the host. That is sending the segment. Okay. And what is meant by this destination port address here? What is meant by this destination port address? This destination port address, it is a 16-bit address. It defines the port number of the application program in the host that is receiving the segment. And what is meant by the sequence number? This field defines a number assigned to the first byte of data contained in this segment. Now, the sequence number, it tells the destination which byte in this sequence comprises the first byte in the segment. Now, what is meant by this acknowledgement number? It defines a byte number that the receiver of the segment is expecting to receive from the other party. And the acknowledgement and data can be piggybacked together. Now, what is the header length? This field indicates the length of 4 byte words in the TCP header. The header length can be between the 20 and 60 bytes and the values between the 5 and 50. Okay. Now here the reserved, this is also one field for this packet. What is meant by this reserved here? This field is reserved for the future bits. And the window size is 16 bits. And this field defines the size of the window in which the bytes that the party must maintain. Okay, and the maximum size of the window is 65,535 bytes. And this value is normally referred to as the receiving window and is determined by the receiver. And the checksum field in TCP is mandatory because here for the error control we are use. Now, what is meant by this urgent pointer? It is a 16-bit pointer field. Is valid only if the urgent flag is set. It is used when the segment contains the urgent data. And what are the options? Here we have up to 40 bytes. It defines the optional information in the TCP header. And what is meant by this control flags? This field defines 6 different control bits or flags. One or more of these bits can be set at a time. Now, what is meant by this TCP connection? Here in the last session, I have already explained about here if we have a connection oriented transmission between the client and server. Okay, then the best example is TCP. Now I can say that TCP is a connection oriented protocol. It establishes a virtual path between the source and destination. And all segments belonging a message are sent through this virtual path. Okay. And now all the data has been transmitted. Then the path is going to be terminated. Or we have to remove or it is going to be terminated. Here, because the TCP operates at a higher level, the TCP uses the services of IP to deliver the individual packets. Now, here, for this transmission, we have 3 main phases. One is the connection establishment. Then the second is connection here between the client and server. Here we have the connection establishment. Then we have this data transmission. Then we have the termination of the connection. Now, Here, the first option is what is connection establishment phase. This TCP uses a three-way handshaking to establish a connection. The three-way handshaking uses a sequence number, acknowledgement number, as well as the control flags and the window size. Now here, what is a passive open and active open? The process starts with the server. The server program tells its TCP that is ready to access the connection. Then we are going to call it as a passive open. The client wishes to connect to an server. Okay, here the server is accepting the connection means it is called as a passive open. But here, if the client wishes to connect to a server, okay, that means the TCP needs to be connected to particular server. Then the client program issues a request for active open. Okay, and the next phase is what we have. What is this data transfer phase? After the connection is established, there is a bidirectional data transmission can take place. Here, the client and server both send the data as well as the acknowledgement. Here, now we have a small picture. Here, the client is sending the data with acknowledgement. One and another client. Here, the client is sending the data with. Once the receiver has been received this packet, then it is going to send the acknowledgement back to the client. Okay, one after the other, this transmission process is going to be done. Okay, now here, what is connection termination? Here, the client and server involved in exchanging data. Okay, once the data is completed, then the connection is going to be terminated. This is usually done by the client only. Okay, and what is meant by this three-way handshaking? It is also used to terminate the connection with the following steps. Once it is going to send the data, then here, after finishing, the server is going to send back the flag with the acknowledgement. Once the transmission is 100% completed, then the client is going to send a request for the connection to be closed. Okay. See you in the next session.